Hello everyone, welcome to Meritnation classes. In this, we will talk about polygons and their properties, part 1. Hello everyone, how are you today? How was the last session? So, are you enjoying your sessions? Sessions are I think cool now because chat is again enabled. Okay, but I will not expect any free hand drawing and all this. Okay, so everyone please concentrate on the class and answer the questions so as to make this session more and more interactive. Okay, I think there is also a music player in between, it pops out also. So please minimize or close your this media player, okay, so that it will not disturb the class in between. Hi friends, hello everyone. So starting with this topic today, the polygons and their properties, unit 3 of your textbook. So first, recording about the curves here. The curves we have simple curves, non-simple curves, closed curves, open curves. Simple curves are the curves like this. You can see here, they are the simple curves. The curves which do not cross themselves. Simple curves are the curves which do not cross themselves. They are called simple curves. So here we have 1 and 2. They are the simple curves because they are not crossing themselves. Then we have non-simple curves which cross themselves. So here we have 2 non-simple curves given in front of you. The 2 curves are crossing themselves. Let's say this curve here, it is crossing at this point. And second curve here, the non-simple curve, it is again crossing at this point. They are the non-simple curves. Then we have the closed curves. The closed curves which are closed, their beginning and end point are the same. The closed curves are the curves which have the same beginning and the end point. So here we have 2 closed curves in front of us. Their beginning and ending, it is same. Then we have here open curves. 2 open curves are given in front of you. One is this, second is this. The curves are not closed. The curves are not closed. You can say their beginning and end points, they are different. The beginning and the end points, they are different. They are called as the open curve. This we have here, example of 2 open curves. I think this is all clear with you about the simple, non-simple curves, closed curves and the open curves here. Next, we will talk about polygons. Polygons, a simple closed curve made of only line segments. Polygon is a simple closed curve. Simple curve because it is not crossed anywhere, and closed curve because its beginning and end point will be same. A simple closed curve made up of only line segments. So if you see here 3 curves in front of us, one is this, second is this, third is this curve. Now in these 3 curves, they all are simple and closed. Why simple? Because they are not crossing anywhere. Closed because their beginning and end point are same. So therefore, a simple closed curve made up of only line segments. Like the first curve, it is made up of 3 line segments. 1, 2, 3. Second curve here, it is again made up of 4 line segments and it is a simple and closed. 1, 2, 3, 4. Third curve, it is again made up of 4 line segments. 1, 2, 3 and 4. And again it is consisting of line segment and again it is a simple and closed curve. Therefore we can see 1, 2 and 3. They can be called as polygons because they are simple and closed and they are made up of only line segments. they can be called as polygons. Next, if we talk about here the other two curves, let's say this is 4, this is 5. In 4 and 5, the curves are this curve here. It is not closed. It is simple because it is not crossing at any point, but it is not closed. Second, if we talk about curve number 5, it is basically closed, but it is not a simple curve. So we can say the curve 4 and 5, one is simple but it is not closed, and 5 is closed but it is not simple. So we can say the 4 and 5, they are not polygon. This is not a polygon, this is not a polygon. Now what are the polygons? Polygons are the simple and the closed curves made up of only line segments. They are called the polygon. Next, we have the classification of polygons. Now polygons are classified according to the number of sides or number of vertices. For example, first is here given as a triangle. Now, in a triangle, we know the number of sides or the number of vertices, they are 3. 1, 2 and 3. And 3 number of vertices. Therefore, it is called a triangle. Triangle, 3 sides or 3 vertices, or you can also say 3 angles. So it is called as a triangle. If anyone is controlling the media player at their side, please close the media player. Okay? Otherwise, it will disturb the whole class. Please close the media player at your end. If someone is able to control the media, okay, because the class will be disturbed in between if media player is open. Now, we're talking about here the concept of triangles. A triangle is containing 3 sides. Triangle is containing here 3 sides or 3 number of vertices. Therefore, it is called a triangle. Try for 3. Fourth one is here a quadrilateral. Quadrilateral means the 4 number of sides or 4 number of vertices. That is called a quadrilateral. So 1, 2, 3 and 4. It is a quadrilateral. Then a pentagon. Penta stands for 5 number of sides or 5 vertices. Then hexagon, 6 number of sides. Then heptagon, 7 number of sides. Octagon, 8 number of sides. Nonagon, 9 number of sides. Decagon, 10 number of sides. In this way, we can classify polygons. Next, we have the concept of diagonal. Now, what is a diagonal? A diagonal is a line segment connecting 2 non-consecutive vertices of a polygon. I am again repeating, a diagonal is a line segment connecting 2 non-consecutive vertices of a polygon. Let's consider the polygon number 1, that is polygon is A, B, C, D. It is a polygon because it is simple, it is not crossing anywhere. Okay. Next, it is closed also. Its beginning and end point is same. Then it number of line segments. 4 number of line segments. 1, 2, 3 and 4. Therefore, it is called a polygon. Now in this case, it contains 4 number of sides or 4 vertices A, B, C and D. Therefore, it is called a quadrilateral. Now, in this we have 2 diagonals. A diagonal is a line segment connecting 2 non-consecutive vertices of a polygon. So, one diagonal is this, second is this. One diagonal is BD, second diagonal is AC. The 2 non-consecutive vertices, they are B and D. They are 2 non-consecutive vertices of this polygon. Then A and C, they are again two non-consecutive vertices of this polygon. Joining two non-consecutive vertices, we are getting two diagonals. Then if we talk about here, the next is, let's say it is a pentagon, because here we have 5 number of sides or 5 vertices. Now two non-consecutive vertices, they are T and A. So one diagonal between them. Then consecutive vertices, they are P and Q. Again one diagonal between them. Then two non-consecutive vertices, they are S and P. Again one diagonal. Similarly S and Q. So we have one diagonal here. And so we can say 1, 2, 3, 4. And then P and R, they are again two non-consecutive vertices here. So joining them, it's a diagonal here. We can draw the diagonals of a polygon joining two non-consecutive vertices in a polygon. Now, if you talk about here, polygon number 3, that is a triangle. In this triangle, we have no two consecutive vertices. In this triangle, the third number, we have no two non-consecutive vertices. Therefore, we can say a diagonal is not possible in the case of a triangle. A diagonal is not possible in the case of a triangle. Therefore, we can say we can draw the diagonals only, or we can begin the drawing of diagonals only from quadrilateral, 4 number of sides, then pentagon, then hexagon, heptagon, octagon, and so on. Next is how to find the number of diagonals in a polygon of n sides. In a polygon of n sides. Last, if you see here earlier, in this number 1, the quadrilateral is a polygon ABCD. It is a quadrilateral. It's a quadrilateral here. So give me a moment guys, because the media player is again popping up and popping out. Just give me a moment regarding this, because the media player is again popping up and popping down. Yes. So here we have the first is the quadrilateral, that is ABCD. Now in this talking about diagonals. So let's talk about how many diagonals are there in a quadrilateral. A, B, C and D. So we see here the formula is to find the number of diagonals in this polygon, that is n into n minus 3 upon 2. N is the number of sides. In a quadrilateral we have n equals 4. N equals 4. So putting this value here, n equals 4 in this formula, it will come as 4 multiplies 4 minus 3 divided by 2. 4 multiplies 4 minus 3 divided by 2. That will become 2 and then 2 here. It will come as 2 multiplies 1. 2 in this case. So we can say number of diagonals in this polygon, it is 2 here. Number of diagonals is 2 for this case. Next, we can talk about here the polygon containing 5 number of sides. That is the polygon number 2 here. Now in this n equals just give me a moment guys, because the media player is again popping up and popping down. Okay, Nebanil. We're getting a report here. Nebanil, please close the media player at your end. Nebanil, please close the media player at your end. Okay, and please do not disturb the class. Okay, Nebanil? I think some students are also here drawing freehand. Yes, Nebanil, please do not disturb your friends and the class. Okay, and do not draw any freehands here in this class. Okay, Nebanil? Try to concentrate. Okay? This could be an interesting class for you. Okay, now guys, what we're talking about here, the polygon that is ABCD. In this, both sides are 4. Okay, so we talked about here how to find the number of diagonals, that is 4 multiplies 4 minus 3 upon 2. This formula. So we'll get here Nebanil, all classes disturbing here. Please close the media player at your end. Okay. It could also interrupt your friends in between. Okay. Now we talk about here second polygon, that is number of sides equal 5. So in this we have n equals 5, and you will get the number of diagonals in this case 5 multiplies 5 minus 3 upon 2. Okay, we put n equals 5 to find the number of diagonals in a polygon of 5 sides. It will become 5 multiplies 2 by 2. Solving this, so we have the number of diagonals of this polygon, it is 5. We can now check it here. In the polygon number 2, in this polygon, there are 5 diagonals in this case, and there are 2 diagonals in this case. Similarly, we can find number of diagonals for a quadrilateral, a pentagon, hexagon, octagon, heptagon, nonagon. The number of sides according to the polygon, and then you can easily find the number of diagonals in that polygon. Now here we have one more example. How many diagonals does each of the following polygons have? A regular heptagon. Now a regular heptagon consists of how many sides? Yes, Nebanil? The media player again popped up here. Control this at your end. Okay. Now, how many diagonals? Okay. Does each of the following polygons have here? First is a regular heptagon. It consists of 7 sides or 7 vertices. You can apply this formula and give your answers. Nebanil, please reply in the chat box if you are doing here, popping up of media player and also freehand. Okay, in figure 3, I am coming out this figure 3 also. Actually, in figure 3, and then we will look at the number of diagonals also. See, in figure 3, they are not diagonals. In figure 3, if we talk about here, Kn, Ln, Mn, they are actually not diagonals. They are just points joining between K and M, M and L, and M and N. M is the interior of triangle here, L, K, M. Because no diagonal is possible in the figure 3. It is just given that no diagonal is possible here. Because there are no 2 consecutive vertices in a triangle. Therefore, it is not possible in that case. Now, after that we have here a regular heptagon. I have got some answers here from you guys. So, you are saying either 7 or 14. Some are saying also 28. Okay. I think for 2 parts you are saying here, for A and B. B, there is no diagonal possible, a triangle. Let us first do the A part here. So, for A part, N equals 7. A heptagon. Now, the formula is N multiplies minus 3 upon 2. n minus 3 upon 2. It is coming as 7 multiplies 7 minus 3 upon 2. And we can solve this now. 7 multiplies 4 upon 2. It will come as 7 multiplies 2. It is coming as 14. 28 by 2. It is coming as 14. The number of diagonals in regular heptagon is 14. Okay. Next, the B part here, a triangle. The triangle contains 3 number of sides or 3 number of vertices. So n equals 3 in the case of a triangle. So we can say number of diagonals are becoming 3 multiplies 3 minus 3 all divided by 2. Now 3 minus 3 is 0. Okay. It will become 3 multiplies 0 by 2. That will become here 0 in this case. So for a triangle, number of diagonals is 0. For a regular heptagon, number of diagonals equals 40. Next is interior and exterior of closed curves. Now, time for a question through poll. I am now publishing a question through the poll here. Everybody, try to participate and give your votes in that question. The first question is here, the poll question. Now, the question is published in front of you. Hexagon consists of how many sides? Option A, you have 6. Option B is 5. So we have here maximum number of votes. They are going with option 1. That is 6 number of sides. Absolutely right. The right answer is here. That is 6. The 5 number of sides, they are contained in a hexagon, not in a hexagon. Okay. The hexagon contains 6 number of sides. Next question is to the poll. How many diagonals does octagon have? The question is, how many diagonals does octagon have? So you have 2 options in front of you, 20 or 18. The formula is, we can see the formula also. Octagon contains 8 number of sides. Octagon contains 8 number of sides. And the formula is n minus 3 upon 2. n minus 3 upon 2. Put n equals 8 and find your answer for this question. So we have here, I am now sharing the results also. So most of the votes are going with option number 1. That is 68% votes are going with option number 1 here. Option number 1 says that 20, 2 says 18. Let's now check this. The formula is n multiplies n minus 3 upon 2. N multiplies n minus 3 upon 2. Now octagon contains n equals 8. So it is 8 multiplies minus 3. 8 multiplies 8 minus 3 upon 2. It will become 8 multiplies 5 upon 2. That is coming as 40 upon 2. It will become 20. Therefore, correct answer is option 1. Right. After that, next topic is interior and exterior of closed curves. Now here we have a closed curve in front of us, and in this, the interior part, this is the interior part here. This is the interior part, and here we have the exterior part. Neban, it is showing that you are playing the media player. Yes, Nebanil? Nebanil, please reply in chat box whether it is done at your end, the popping up and popping down of this media player. Yes, Nebanil? Because the media player is again popping up and okay, no, not on your side. Okay, Nebanil. Yes, I understand it is irritating, but it is happening here in the class. Okay. Yes, definitely. I will again explain you about the interior and exterior. If anyone is controlling here the media player, please don't do this. It is whole disturbing your friends also and the whole class here. Okay. Yes. Okay. Now here we have, this is the interior basically, interior, and this is the exterior. Interior of this polygon, that is the hexagon, and exterior of this hexagon. Okay. Now interior is whatever is inside the boundary of the hexagon. That is called the interior of a closed polygon. And then exterior is whatever point is at the outside of the closed polygon. It is coming under the exterior of that closed polygon. Let us take here 2 points. The point is, let's say it is A. The point A is inside this polygon, and then the point B, it is in the exterior, at the exterior of this polygon. So A is in the interior of the polygon, B is in the exterior of this polygon. Okay. This is the concept of interior and exterior of closed curves. Now the question could ask by you, what about the point at the boundary? Let's say the point here, the point C at the boundary. The point C is neither in the interior nor at the exterior. Neither in the interior nor at the exterior. It is just on the boundary or on the curve of this closed curve or polygon. Okay. Next is convex and concave polygons. A convex polygon is a polygon that has no portion of its diagonal in its exterior. Nebanil is showing that you are drawing here and still you are not seeing that in chat box. Okay. It is showing here, Nebanil. You are trying to draw any freehand here. Okay. So please just concentrate here. Do not make any changes with the media player or the freehands here if anyone is doing here. Now the convex polygon is a polygon that has no portion of its diagonal in its exterior. That means if you talk about here the polygon 1 and 2. In these two polygons, diagonals, if you draw diagonals here, one diagonal is coming like this. Second diagonal is here between these two non-consecutive vertices. Now you see here, both the diagonals are in the interior, not at the exterior. That means the polygon that has no portion of its diagonal in its exterior, it is called a convex polygon. Similarly here, second polygon. If you again draw diagonals here, all the diagonals will be in the interior of this second polygon. So we can say the first and second, they are the convex polygons. The two are the convex polygons. This one and this one. Because all the diagonals are in the interior, not even a single diagonal is at the exterior of this polygon. Then we talk about here third and the fourth polygon. This and this. If we draw diagonal of this polygon number 3, one diagonal is between this two non-consecutive vertices. Second diagonal will be between these two non-consecutive vertices. Let me just again magnify this picture a little. Now, let me name its vertices A, B, C and D. Now we join here two non-consecutive vertices, that is A and C. Joining A and C. This we have one diagonal here between these two non-consecutive vertices. Second diagonal is between B and D here. Now we see here this diagonal. It is in the exterior of this polygon ABCD. Exterior. So definition says that any polygon which has some portion of its diagonal or complete diagonal in its exterior, that is called a concave polygon. Similarly, figure number 4, this polygon here, if you draw its diagonal, this diagonal is again here at the exterior of this polygon. Diagonal is again at the exterior of this polygon. Or you can say like this. That means it is again come under the category of a concave polygon. So it is again a concave polygon here. Third and fourth, they are concave polygon. First and second, they are convex polygon. Okay. After that, we will talk about here regular and irregular polygons. Now, a regular polygon, a polygon in which all sides and angles are equal. It is called a regular polygon. Irregular polygon, a polygon which is not regular. That means not all sides and not all angles are equal. Called an irregular polygon. You can see here in the figures. Let's talk about the first figure here. Let's suppose this polygon, it is an equilateral triangle. Equilateral means all its three sides are equal. And we can say all its three angles are also equal. Guys, just give me a moment. I am again coming back. I am just log out and log in once because the media player problem is coming again and again, popping up and popping down. Okay, so what you are talking about? The regular and the irregular polygons. Yes, regular are the polygons in which all sides and all angles are equal. That is, this is a regular polygon here, an equilateral triangle. All sides and all angles are equal. Then figure number 2 also, that is this figure, a square. A square. In square also we have all sides are equal and all angles are equal. Angles are also 90 degrees each in a square. Therefore again, it is a regular polygon. Similarly, if we talk about here, a regular pentagon, talk about a regular pentagon having all its sides equal and all its angles as equal. Okay, so now after that we have third polygon here, that is, today I think media player is playing with us here in this session. Okay, now third polygon is, let me change the color. It is a regular pentagon containing all sides as equal and all angles are also equal. So it is called a regular pentagon. We use specifically here regular because its all sides are equal and all angles are equal. Now we talk about figure number 4. In this, if you see, not all four sides are equal. Not all four sides are equal here. Okay, so whoever putting up this star sign here, the free hand, please refuse it. Okay, please concentrate in the class and not disturb your friend, because media players already disturbed us very much in this class. Arya, why are you drawing here star smiley? Yes, Arya. I have to block you from the class because it is very disturbing. The media players already disturb us so much. Okay, Arya? Yes. So here we have now the fourth polygon. In it, not all sides are equal and not all angles are equal. So it will come under an irregular polygon. Then the polygon number 5. Again in this, not all 5 sides are equal and we can say not all angles are equal. So it is an irregular polygon. For example here, if sum of the measures of all the angles of a regular pentagon is 540 degrees, then find each angle of the pentagon. Everyone, please tell how many angles are there in a pentagon? How many angles are there in a pentagon? The number of angles are 5 or 6. You can write in chat box. The number of angles are actually they are 5. Yes, they are 5. So in this way we can say 5 multiplies x. Let each angle be x degrees. So we can say 5 multiplies x equals 540 degrees. Because it is a regular pentagon contains all angles as equal. So we can say 5 angles, they will be 5 multiplies x equals 540 degrees. And then we can solve this. X equals, everyone, please calculate this and write your answer in chat box. X is coming out to be 540 divided by 5. It is coming as how much? Yes, it is coming as 108 degrees. So x equals 108 degrees. Therefore, each angle of the pentagon is 108 degrees. Now, one question to the poll. Question is coming as in front of you. A regular polygon is a polygon in which all angles are equal but not all sides are equal. Is it true or false? The question about the regular polygons and irregular polygons. A regular polygon is a polygon in which all angles are equal but not all sides are. Actually, this is a false statement because in a regular polygon all sides and all angles are equal. So we have here the maximum number of votes are going with option number 2. It is a false statement. Okay, very good. Next, moving on to the next poll question now. The question is, if sum of the measures of all angles of a hexagon is 720 degrees, find the measure of each angle. Now in a hexagon, we have number of equals 6. Okay, please consider it as a regular hexagon so that all angles are equal. In this regular hexagon, number of angles are 6. So we can say 6 multiplies with x, it is 720 degrees. So we can say 6 multiplies x, it is 6 multiplies x equals, so x is coming out to be 720 by 6. That is coming as 120 degrees. So correct answer is here option 2. How many students have given the correct answer as option 2? 80% students. Very good. That means you are able to understand these concepts. So option 2 is the correct option. Nice. Next, moving on to the next concept now. Example is here. If one side of a regular hexagon is 7.5 centimeters, then find the perimeter of the hexagon. It is again a regular hexagon. Okay, it contains 6 number of sides, 6 number of equal sides. Then perimeter, If you calculate the answer, you can write in the chat box the answer, and then we will check it. How many centimeters will be the perimeter of this hexagon? Okay, so answers which I am getting here, it is coming as 45 or 67. Someone has given here 5 also. Nathaniel has given here 5 also. So now we will calculate it, which is the right answer. 6 sides. So we can say perimeter of this hexagon, it will be 6 multiplies each side or one side. 6 multiplies 7.5 centimeters. Calculating this, it is coming as 45.0 centimeters. And this we can write as 45 centimeters. The perimeter is coming as 45 centimeters. So most of the answers are correct here in chat box, that is 45 centimeters. Okay, Nathaniel, it is 45 centimeters. Next, now angle sum property of a quadrilateral. Before the angle sum property, I would like to take one more question through the poll, and the question is now published in front of you. Okay, before taking this question, let's complete this concept, because the next poll question is on these concepts only. Now it is the angle sum property here. Sum of the measures of all angles of a quadrilateral is 360 degrees. In a quadrilateral we have total 4 number of angles or 4 sides. Sum of all these angles, it is 360 degrees. That means we can say, if this complete angle here, it is angle 7. This complete angle, it is angle 8. So we can say sum of all 4 angles, that is angle 2 plus angle 7 plus angle 8 plus angle 5. It will become equals 360 degrees. That is the angle sum property of this given quadrilateral. What about angles of a triangle? Sum of all 3 angles of a triangle is 180 degrees. Now, angle sum property for a polygon having n sides. Some of the measures of all angles of a polygon having n number of sides, it is given as n minus 2 multiplies 180 degrees. That means if you are given a polygon with, let's say, 5 number of sides, that is pentagon, or a hexagon, 6 number of sides, or heptagon, 7 number of sides, then we can apply this formula and calculate the sum of all angles of that particular polygon. That is n minus 2 multiplies 180 degrees, where n is the number of sides in that polygon. Example of this, find the sum of measures of all angles of a polygon having 12 sides. Sum of measures of all angles of a polygon having 12 sides. The formula is here, n minus 2 multiplies 180 degrees. N minus 2 multiplies 180 degrees. The number of sides are 12 here. That is 12 minus 2 multiplies 180 degrees. It is coming as 10 multiplies 180 degrees. It will become 1800 degrees. So we can say sum of measures of all angles of polygon containing 12 sides. It will be 12 minus 2 multiplies 180. That is coming as here 800 degrees for this example. Now, turn of a poll question. The question is now published in front of you. the sum of measures of all angles of a polygon having 14 sides, that is n equals 14 in this case, and the formula is, you can apply here, n minus 2 multiplies 180 degrees. The two options are given in front of us. 2160 degrees. Second option is 2260 degrees. Now I want to show the results also. The maximum number of votes are going with option number 1, that is 2160 degrees. Let's now calculate this. So n in the portion here, n is given as 14. The formula becomes 14 minus 2, n minus 2 multiplies 180 degrees. Minus 2 multiplies 180 degrees. That will become 12 multiplies 180 degrees. That is coming as 0, 2160 degrees. Some of the measures of all angles of this polygon, it is 2160 degrees in this case. That is option 1. So we have here 74% students are correct in giving the answer as option 1. Example we have now, find the values of x, y and z for this given figure. How to find your x, y and z? If you get the know the answers, you can write in the chat box and then we can cross check it. X equals 150 degrees. Please tell how, which property? It's a linear pair. X and 30 degrees, they are forming a linear pair. Okay, so we have here x 30, we are forming a pair. So what's the linear pair? Let's just discuss this first. Let's take a figure here, a straight line like this. A ray on this line touching the given line, let's say at point A. Now angles made by this ray on this line, that is angle 1 and angle 2. They are called as linear pair of angles on a line. They are called as a linear pair. So we can say here linear pair means angle 1 plus angle 2 equals 180 degrees. Now in this portion we have angle x and angle 30 degrees. They are again forming a linear pair, angles on a straight line, this straight line here. So we can say angle x plus 30 degrees equals 180 degrees. From this, x will come as x equals 180 degrees minus 30 degrees. It is coming as 150 degrees. Then angle y and 60 degrees. We are again forming a linear pair. So y plus 60 degrees equals 180 degrees. From this we will get angle y equals 180 minus 60 degrees. So y is coming as 150 20 degrees. Then what about angle Z? Here, now this angle we can find here, let's say it is angle 1. Using the angle sum property of a triangle, that is angle 1 plus 30 degrees plus 60 degrees equals 180 degrees. This we have angle 1 equals 180 degrees minus 30 plus 60, that is 90 degrees. So angle 1 is coming as 90 degrees here. So angle 1 is 90 degrees. Now angle 1 and angle Z, they are again forming a linear pair. So we can say angle 1 plus Z equals 180 degrees. From this we will get Z equals 180 degrees minus angle 1. Angle 1 is 90 degrees. So angle Z, it is coming as 90 degrees for this case. Angle Z is 90 degrees for this case. Okay? That means the property of linear pair that we need to apply here, find angle X and angle Y. Then for angle 1, we have used here angle sum property of a triangle, and then again angle 1 and angle Z, they are forming a linear pair, and then finding angle Z, that is coming as 90 degrees. Yeah, one more example here. Find the value of X in this given example. How we can find here the value of X? Now first we will find here the value of angle 1 and angle 2. So we can again say here 55 degrees and angle 1, they are forming a linear pair. That is angle 1 plus 55 degrees equals 180 degrees. And from this angle 1, it will come as minus 55 degrees. That is coming as 125 degrees. 125 degrees. Then angle 2, similarly angle 2 again, angle 2 plus 55 degrees equals 180 degrees, forming a linear pair, and then angle 2 equals 180 degrees minus 55 degrees. That is coming as again 125 degrees. Now we will use here angle sum property for a pentagon because it contains 5 sides, 1, 2, 3, 4 and 5. The angle, this angle is here, it is 90 degrees. Now finding here angle X. So we have sum of angles of a pentagon. Pentagon contains 5 sides, so we have n equals 5 and equals 5. Sum of all angles of a pentagon, the formula is n minus 2 multiplies 180 degrees. That will become 5 minus 2 multiplies 180 degrees. That will become 3 multiplies 180 degrees. That is coming as 540 degrees. Sum of all angles of a pentagon. Now it is becoming here angle X plus angle 1 plus 120 degrees plus angle 2 plus 90 degrees. It will become here sum of all angles of this pentagon, that is 540 degrees. Finding here angle x. So it is coming as x plus angle 1. It is 125 degrees plus 120 degrees plus angle 2. It is again 125 degrees plus 90 degrees equals 540 degrees. Now solving this for x from this equation, we will get here the value of x, that is coming out to be 80 degrees. We can solve this. It is coming as x plus 125 plus 120, that will be 245 plus 125, 345 plus 25, it will be 370 plus 90, that will be 460. X plus 460 equals 540 degrees. And then solving this, x is coming out to be 80 degrees. X is coming out to be 18 degrees for this example. Okay everyone, so in this way we can use the property of linear pairs and then the angle sum property for a polygon having n number of sides, find the sum of all angles and then calculate x in this. Okay everyone, thank you for today. So we are now concluding our session. Bye bye and take care. Keep studying and keep revising. Thank you very much. Bye bye. Hope the trouble of media player does not trouble you really, because it was very troubling today. But I hope next time it will not be there. Okay, thank you very much. Bye bye and take care everyone.